video, I will explain how to compute continuous compounded interest. So first of all, we start with a simple interest. So you have an amount of, whatever you want, say 1,000 euros, and invested an interest rate of 10%. We convert this to mathematics, which is expressed as fractions, 10 over 100, 0.1. So invest your 1,000 euros. For the interest rates are always expressed annually. So you invest this for a year, and this gives you 10% of 1,000, which is 100, and that's the interest. Of course, your money is in the bank, so you not only have the interest, you have your principal amount, and total you have 1,100 at the end of the year. 1,100 is, as I just said, the principal amount, 1,000, your amount K, plus 10% of 1,000, which this is the interest. You can write this in general as K, 1,000, plus 10% the rate of K of 1 plus R over K. That's simple interest. What is compounded interest? This is when you invest, for example, say you invest for 2 years at an amount of 1,000 at a rate of 10%. So you have your amount here, you invested for 1 year, and you get K times 1 plus R. So this amount of money has grown. And what you do now, you don't take the interest out of the bank, but this bigger amount you invested for 1 more year, and you get a bigger amount of money, which will be equals to, from here to here you multiply by 1 plus R, so again you multiply 1 plus R, the amount here so will be 1 plus R times 1 plus R K, or K times 1 plus R squared. This key point here is the part of compounded, which the interest in the middle is not withdrawn from the bank, but is invested again. So to repeat, you have a small amount, multiply by 1 plus R to get something bigger, leave the interest in the bank, multiply 1 plus R to get something bigger at the end of the second year, leave all together in the bank, get something bigger at the end of the third year, so 3 years will be K times 1 plus R to the third, and so on. Can we repeat this process more frequently? What happens? Let's go back to the original idea of K equals 1,000 with an interest rate of 10%. And as I said, the rates are annually paid. No, but suppose the bank decides to make a deal with you, and instead of paying everything at the end of the year, so you invest on January 1st, and here 1,000, and at the end of half the year, on June 30th, the bank gives you 5% of interest with the condition that you keep it in the bank. So at the end of December, the bank will give you the first 5% and the second 5%. Okay, so you started with K, and at the end of the half of the year, you have K times 1 plus the rate, but the rate of the year is 10, so the rate for the semester is half of it. R over 2 is the interest rate for half a year. And then you invest that, you keep it in the bank, so at the end of the year you get K1 plus R over 2 squared. How much money do you have? Have you earned more or less than before? Previously, we have 1,000 times 1 plus 0.1 was 1,000 times 1.1, which is 1,100. And now we have 1,000, 1 plus half of the interest rate, 0.05, but twice square, and this is equal to 1,102.5. So you earned a little bit more. What if the bank decides to pay every 3 months? So if it pays every 3 months, it will pay you like 4 times a year. So what do you will have? You have your amount at the end of the year. This is at the end of 1 year. You have the amount initial and then the interest rate, which is the interest divided by 4, because you have 4 times a year. So you have 1/4 of the rate, but this happens 4 times. R over 4, 1 plus R over 4 times 1 plus R over 4, which is K times 1 plus R over 4 to the 4th power. Let's see how much this comes in our example. K was 1,000 and the rate was 10%. So the rate divided by 4 is 0.1 divided by 4, which is equal to 0.025. So at the end of 1 year, you will have 1,000 K times 1 plus R over 4 to the 4th power. This means 1.025 to the 4th power. This is equal to 1,103.812 blah blah blah. Little bit more. You see, the more times the bank pays you, the more money you make. That's obvious because every time you reinvest everything. Okay, what happens as we keep doing this over and over? Assume we can do this infinitely many times. Meaning that the bank can pay you a little bit every second, every millisecond, every 10th of a millisecond, everything. Okay, you will have that K is the amount invested, R is the rate of investment, and you have in K times per year. So you will have K times 1 plus R over K. Like here you have R over 4. So R over the number of times, because the interest has to be divided, raised to the kth power. Like here you have raised to the 4th power. And what happens when this goes to infinity? When K goes growing and growing to infinity. So this, if you check this mathematically, I can do it later, but there is no need. This is K, which is fixed, e to the R. So that's the amount you get. For example, if K were 1,000 and the rate is 0.1, at the end of 1 year, you get K times e to the 0.1, assuming you could invest the money every second, no, every millisecond, no, every smallest amount possible of time, and the investment gets reinvested. How much is that equal to? This is equals to 1,105.17 approximately. That's for a year, and this is called continuous or continuously compounded. Sorry for this mess here. Compounded interest, meaning that the money is invested non-stop continuously, and if K is the principal, the amount invested, and R is the rate, after 1 year you will have K times e to the R. After 2 years you will have K times e to the 2R, and after T years you will have K times e to the TR. And this is the money for a continuously compounded interest investment. We do better than this? Can we study something different? Yes. Right now it has continuously compounded, but so far we have assumed that an amount of K equals 1,000 euros, or whichever amount you want. This is at the beginning of your investment. And the interest, K is equal to 0.1, 10%. This is done continuously. But we can assume, why not, that the investment is also done continuously. Investment is continuous. I don't go to the bank and I give the amount on January 1st, but I go to the bank on January 1st and invest a little bit, come out of the bank and go back immediately to invest a little bit. So here's my bank. Here's the bank. and then I go, put some money, go for a walk, put some money, go for a walk, put some money, go for a walk continuously. Obviously, now that we are not allowed to go to the streets, you cannot do that. So after the coronavirus is over, you do these things. This is called continuous investment. And what happens? Suppose at time t, your investment, sorry for the handwriting, but investment is given by the function f of t. What happens? When you start, t equals 0, you invest by f of t. Let's assume 1 year, because it's easier for the time being. For 1 year, this is going to be rather f of 0, this is going to be 1 year. Now, at a little bit later, t equals to something, say 1, you invest an amount f of 1, this is for 1 year, minus a little bit of time, right? Because it has lapsed some time from here to here. Then you wait a millisecond, but you wait something, and your second investment, t equals to whatever, you invest this amount of money for 1 year, but a little bit less, time. As you are investing continuously, here is your figure on time, that's the beginning, and this is 1 year later. What you invest here stays for 1 year. When you invest a little bit later, it stays for less than a year, here less than a year, here even less, and at the end what happens? How do you get to this formula? Mathematically, we have at the first time t equals 0, we get the amount invested times e to the 1 year times the rate. At t1, whatever time has lapsed, we get the amount invested, and that amount is lasting for 1 year minus t1 times the rate. When we invest again at another time, we are investing, this is the amount invested, and by the formula here, by this formula here, this invested amount is e to the 1 minus the time lapse, which is not invested, it's sort of wasted, times the rate. And we have to add all this up. Okay, mathematically, if you add all these things, what you get is the integral from 0 to 1 of f of t e to the r1 minus t dt. If instead of that, what you have a continuous investment on a continuously compounded interest for t years, amount k with an interest rate. Remember, interest rates are annual. So after t years, you have an amount, you get, what do you get? This is wrong. In general, if you have a continuous investment function, f of t, this means the amount f of t invested at time t instead of a fixed amount of k, and we have an interest rate of r, and remember, interest rates are always given annually, and we have a continuously compounded interest, and for a time k, the time is t, not k, that will confuse, the time is t. So what happens, how much money you have at the end of the period? Well, at the end of the period, you will have the integral from 0 to t of time. Now, how much you invest, and it's compounded, so it has to be an exponential, and is the rate of the total time minus the time at which you invested dt. For example, investment function is f of t is equals to t, and your interest rate is 8%. That's 0.08, and your amount is 3 years. So at the end of 3 years, investing continuously by this function, you will have the integral from 0 to 3 of f of t, which is t, e to the 0.08, the amount 3 years, minus t dt. Okay, this in mathematics is called the future value of the investment, because it's the value you get at the end. So the future value of a continuous investment stream f of t at a rate of r over a period of t years. Let me write here the future value. Value is equals to the integral from 0 to t of the investment function e to the rate times total time minus local time dt. Observe this can be written as the integral from 0 to capital T of f of t e to the r capital T e to the minus rt dt, or a future value is equals to, this is a number because r is a rate fixed and t is the period, the total period is also fixed. So we can write this like e to the rt, the integral from 0 to t of f of t e to the minus rt dt. And this is the money you will get at the end of your investment period. To recap, we have two things. One is simply when we invest amount k for a period of t years, continuously compounded at a rate r, what we get at the end of the period is k times e to the rt. And when we have an investment continuous f of t for a period of t years, and r, what we get at the end is e to the rt, the integral from 0 to t of f of t e to the minus small r small t dt. See here, this amount, this formula is called the future value of your investment. There is one more thing that you need to know, which is called the present value. And what is the present value of an investment? So the present value is the amount A, let's say A, that you should invest now, one single time right now. So at the end of the period, you get the same as the future value. You get the future value. In other words, if you have an stream f of t invested and you get some future value, how much money you should put now to get exactly the same value? Meaning, how much this is worth right now, because if this amount A were invested now, you have it in your pocket. It's present money that gives you this future money. This is easy to compute. For an income stream, f of t, for a period of t years at a rate, the future value we have seen is equals to e to the tr for the integral from 0 to t of f of t e to the minus rt dt. Now suppose what I want to know is what amount A I have to invest today for t years continuously compounded r to get this amount. But this A is fixed, is the money I have now. How much money I'll need now to produce this much in the future? Okay, this formula was done here. It was K, but I'm calling A, doesn't matter. This formula is right here. K, A is the same thing. So here is A times e to the tr. So these two things have to be equal. So this means A e to the tr is equals to e to the tr times this blah 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 integral. So if A is equals to this integral from 0 to t f of t e to the minus rt dt, if I invest this amount now for t years continuously compounded r, I get the future value. And this amount here is called the present value. Means how much money I have to invest now to get this in the future. Here, there's a small difference. Here you have a continuously invested amount of money. Here is a fixed amount invested at the beginning. Simply that. If, for example, here you have a business and your business is producing money and you invest the money of your business. And here, for example, you are rich and you have some rent and you invest some money, some capital right now. That's the difference. So future value is equals to e to the tr, integral from 0 to t, e to the minus r t f of t dt. I have interchanged the order, but doesn't matter. And present value is equals to, here you have it, is the same as here. The only thing that is missing here is the exponential, so is this part here, so is e to the minus tr times future value. Because if I multiply the future value, this amount here, if I multiply this by this, I get exactly only the integral. Let me recap it once more. Future value is equals e to the tr, the integral from 0 to t, f of t, e to the minus r t dt. And present value is e to the minus tr times future value. This is the money you get in your business investing little by little. This is the money you need so that at the end of the period is the same to the future value. And these are the two formulas you need to learn. And that's more than enough for today.